All right, so the next part of our Unit 2 is Module 1.4. And in this one, we are going to compare ratio relationships. And so, learning target, I can compare ratio relationships that are shown using different representations. It could be a word problem, it could be a table, a ratio table, it could be a graph. So looking at those different representations, we should be able to compare ratio relationships that are shown. And our vocabulary, we have ratio. Of course, a ratio is a comparison of two quantities using division. And ratio tables are tables that are actually showing equivalent ratios by scaling forward or scaling back. And we've talked about that in the previous lessons that I have filmed for you all. Okay, so let's go ahead to my smartboard. And here is a question that I have. All right. So we are going to use a graph in order to look at the different representations and try to put all the different questions that we have over here in order to compare. All right. So ratios for ingredients in dog food vary among companies that manufacture it, right? And company A advertises 25 grams of protein for every cup of dog food. So if I'm looking at that, I know for company A, what would my ordered pairs be? So for one cup of dog food, I'm going to have 25 grams of protein. So for 2 cups of dog food, so these become my ordered pair. Okay, so for company A, I have 225. So for 2 cups of dog food, I would have 50 grams of protein, right? Because 25 times 2. For 3 cups of dog food, I would have 25 times 3, and that gives me 75 grams of protein. And for 4 cups of dog food, I would have 25 times 4, which is 100 grams of protein. So those become my ordered pairs for company A. All right, let's look at company B. And for company B, 2 dog food cups, the protein for that is 44. So if you think about it, how much would it be for one? It would be, you're going to scale back, and 44 divided by 2 gives me how much? 22 grams of protein for 1 cup. Okay, so this one, I'm getting 22 grams of protein for 1 cup. For this one, it was 25 grams of protein for 1 cup. Okay, let's look at company C. And in this one, I can see that, of course, this one down here is going to be my cups of dog food, as you can see. Look, I have my cups of dog food over here. And this company is giving me, for 1 cup, I have 20 grams of protein. For 2 cups, I have 40 grams of protein. Okay, so now think about what I said. Company A, we had 25 grams for 1 cup. Company B, I have 22 grams for 1 cup. And company C is 20 grams for 1 cup. So think of this. If I put all of them into the same graph, which line would be the steepest? So of course it will be the one which has the maximum grams of protein per cup, right? So that would be company A. All right, and those become my ordered pairs I was talking to you about. The cups of dog food become your x-axis, and the grams of protein, that is going to be my y-axis. So I'm just going to show you a graph where all three of them are on the same graph over here. Okay, so here we go. Look, there we go. So company A, company B, and company C. All right, so as you can see, this is company A, the blue one on the top. So I told you which graph is going to be the steepest. Just by thinking of how much would be for 1 cup, I can already know that that graph is going to be the steepest graph. Okay, so For 1 cup for company A, we had 25 grams of protein. For 2 cups, we had 50. For 3 cups, I had 75. And for 4 cups, I had 100 grams of protein. And that was my company A, right? For company B, it was, for 1 cup, it was 22 grams. For 2 cups, it was 44. For 3 cups, it is 66. For 4 cups, it is 88 grams of protein. And then for company C, we had for 1 cup, it was 20 grams of protein. For 2 cups, 40. For 3 cups, 60. For 4 cups, it was 80 grams of protein. All right, so you're drawing a dotted line through the points to determine which relationship has the steepest graph. And of course, the graph for company A is the steepest. And the graph for company B is steeper than the graph for company C. This means that company A has the greatest ratio of protein to cups of dog food. So just by having those numbers in our head in the beginning, knowing that how much per cup, where the numerator was the highest or that ratio was the greatest, of course that graph is going to be rising faster or at a steeper rate than the other graphs, okay, just by looking at this. All right, so let's talk about another problem, and let's look at this one. All right, here we go. So Paulo's Pizzeria advertises 24 pepperonis on every 12-inch pizza. The relationship of pepperonis to pizza size for 2 other pizzeria is also shown in the table and graph. Okay, so think about what I said earlier, 24 pepperoni for a 12-inch pizza. Okay, so if I'm going to divide that by the size, okay, think about what it's going to be. So 24 for 12. So if I divide 24 by 12, what do I get? I get 2 pepperoni per inch, right? Let's look at the next one. The slice of pie. You have 15 pepperoni on 10. So if I think of unit rate, how much on 1? It's 15 divided by 10, and I know I'm going to get 1 5/10, right? Which is less than 24 divided by 12, which I had done earlier. Okay, so I had got 2 pepperoni per inch over there. Here I have 1 5/10 per inch. All right, then let's look at this one. And I have 20 by 8. Okay, so I have 20 by 8 over here. So let's look at these, and I'm going to graph them all into the same format. Okay, so you can either find the unit rate or we can graph them on the same thing. Remember that to compare that, you're trying to put them on the same format, and we are using these ordered pairs over here. So for the, if I look at the scaling for Paulo's Pizzeria, you're going to use scaling to write the ordered pairs. Okay, so we have, let's go here. I'm going to just show you this really quick. And here, there we go. Trying to graph it all on the same thing. All right, there were 4 different over here. We have the slice of pie. So look, the pizza place, and we have Paulo's Pizzeria, and we have the slice of pie over here. Okay, so this is the pizza size in inches, and that's the pepperonis over there. Okay, so the pizza place, so that's the first one, and this was talking about 8 inch over here, the pizza slice, 8 inches, and that had 20 pepperoni on that. So as you can, that is the graph we had earlier. So 8 inches and 20 pepperoni. For 12, we have 30. For 16, we have 40. So that was the pizza place. All right. Then if you're talking about Paulo's Pizzeria, it was 24 pepperonis on every 12-inch. Okay. So Paulo's is the green one. Okay. So for every 12-inch, so here we go 12, and that is 24. Okay. And then of course we could have done the unit rate, or we could have gone down. So for 10 we have 20. All right, and that's how this line has been graphed, by looking at those ordered pairs. Okay, you can make a ratio table. And so here, that was the first one: 8, 16, 10, 20, 12, 24, 14, 28, 16, 32, etc. Okay, and then we have the slice of pie. And here are the ordered pairs for the slice of pie, which was in the table format. So you put it into the ordered pairs: 10, 15, 12, 18, 14, 21. Okay. So the red one, the pink one is the slice of pie. All right. So look, and we have 10, and this is 15. And we have 12, and we get 18. We have 14, and we have 21. Okay, so once again, please look over here. It's saying the ratios of pepperonis to pizza size for the pizza place. I have already been graphed for you. Okay, and now we are looking at this. This for slice of pie, I've already told you that it was 10, 15, 12, 18, 14, 21. Those have been graphed. And so we draw a dotted line through the points because the graph for the pizza place is the steepest, and the graph for Paulo's Pizzeria is steeper than the graph for slice of pie. And this means what? The pizza place, okay, that is the blue one, the pizza place has the greatest ratio of pepperonis to pizza size in inches, followed by Paulo's Pizzeria, which is the green one. So look, this is the steepest, this is the less than that, and then you have the slice of pie, which is this one. So this has the most pepperoni, and the greatest ratio of pepperoni to pizza size. All right, and that's basically how you can just show it as a graph. But there's another way that we can show this, and which would be by using tables to compare ratio relationships. So let's go ahead and learn about that one. Okay, so let's look here. So another way to compare a ratio relationship is to use tables. For example, a comparison of 3 smoothie recipes shows that recipe A has a blueberry to strawberry ratio of 8:2. Recipe B has a ratio of 5:1, and recipe C has a ratio of 10:3. So you can use tables of equivalent ratios to determine which recipe has the greatest ratio of blueberries to strawberries. Okay, so I'm just going to create the tables with the 3 recipes. And so all right, here we go. So we have recipe A, and I'm going to create a table for each of those recipes. Okay, so here is my table, and I have blueberries. Okay, blueberries to strawberry is what I am comparing. 2 strawberries. Okay, and then I'm looking at what is the ratio that they have given me is 8:2. 8:2. All right, so then I'm going to use multiplicative structure. And what is 8? 8 times 2 is 16. 2 times 2 is 4. right? Multiplicative structure, and I'm scaling forward, and then I have 8 times 3 is 24, and 2 times 3 is 6. So this is what my table is going to look like for this one. Let's do recipe B. So for recipe B, so this was recipe A, this is recipe B. I'm going to do the same thing. Okay, and I'm going to have my blueberries over here. I'm going to have my strawberries. Okay, and then I'm going to create equivalent ratio table over here. And so my ratio was what for recipe B was 5 to 1. So 5 over 1. Using my multiplicative structure or scaling up, it'll be 10 over 2. And I get 15 over 3. 20 over 4. 25 over 5. 30 over 6. Okay, and then for recipe C, recipe C, same thing. I'm going to make another table. Okay, and then of course I have my blueberries. And strawberries. Okay, and this ratio is in the format of 10 to 3. So 10 over 3, and then using scaling up, I get 20 over 6, 30 over 9, etc. Okay, so now what we're going to do is you're going to use scaling, of course, to write equivalent ratios, which I just did, and then you can compare the ratios when one of the quantities in each relationship is the same. Okay, so one of the quantities. Now let's look at this. The 2 as a denominator in all of them for strawberries is these two have it, but not all 3. Okay, 4 is only in those 2. 3 is only in these 2. So what is common is that 6, right? So what I'm going to do is I'm going to take this, because I have 6 here, I have 6 here, and I have 6 here. So I'm going to circle this one, because this is what I have common. Okay, and so recipe B has a ratio of, because when I have the same denominator, then I'm looking at the numerator and I can see which numerator is the maximum in that case when I am comparing. Okay, so a recipe A has 24 blueberries for 6 strawberries. Recipe B has 30 blueberries for 6 strawberries. And recipe C has 20 blueberries for 6 strawberries. Okay, so recipe B has a ratio of 30 blueberries and for every 6 strawberries, which is followed by recipe A, which is the next. This is the highest, and this is the next, which is 24 over 6 or 24 to 6. And then recipe C has the least over here, which is a ratio of 20 to 6. So recipe B has the greatest ratio of blueberries to strawberries. So this recipe has the greatest ratio. So this is another way that we can compare ratios. Okay, so I am going to go ahead and show you another one, and this is the last example when I'm comparing. So let's look at this using tables. All right, so Roman is considering different bird seeds to fill his bird feeder. Measured in ounces, recipe A has a sunflower seed, to peanut ratio of 2 to 3. Okay, so I'm going to go ahead and again start making out a ratio table for each recipe, and then I'm going to find the equivalent ratios to compare the relationships. Okay, so once again, let's do this a little bit like this so I have room to write. And okay, sunflower seeds to peanuts, and as you can see, what is my ratio to that of that one is 2 to 3. So I'm going to write out my ratio. Okay, and then I'm going to find equivalent ratios. So then I have 4 to 6. Okay, I have 6 to 9, and I have 8 to 12. Okay, so this is my recipe A, and then let's look at recipe B. Recipe B, and again going to draw a table, and sunflower seeds to peanuts, and over here I have the ratio of 3 to 4. So I'm going to create equivalent ratios with 6 to 8, 9 to 12, and then I have 3 times 4, which is 12, and 4 times 4 is 16. So here's my equivalent ratio table. And then recipe C. Recipe C. Again, going to make a table, and I have sunflower seeds and I have peanuts, and this ratio is 5 to 6. So 5 to 6, and then I am going to create an equivalent ratio. This is 10 to 12. I have 15 to 18. And then I have 20, because 5 times 4 and 6 times 4 is 24. Okay, so now once I have created it, we are looking at, okay, which one is common over here. So we're going to look at the denominators, or how many peanuts. So 3 is not in all, 6 is not in all, 9 is not in all, 8 is not in all. So which one is the common one? Is this one with the 12 and 12. Okay, so now that I've circled that, you can see recipe A is, what is my ratio? 8 to 12. Okay, what is my ratio in this one? It is 9 to 12. What is my ratio here in recipe C? 10 to 12. So when I look at these ratios, because 10 is greater than 9 and 8, the recipe with the greatest ratio of sunflower seeds to peanuts is recipe C. All right, and so that's how we do use equivalent ratio tables in order to find these kind of problems. Okay, so once again, this was our module 1.4, comparing ratio relationships. So either you're converting them you're putting them all into a graph, we're putting them all into a table in order to compare the ratio relationships. All right, have a great day.